Good morning, and even though it is in the morning, I'm going to present my work about the secrets of the nightlife of red-necked Nightjars. My name is Paula Hidalgo, and I am an aspiring PhD student at University of Pablo de Olavide in Seville, Spain. Mobile animals in nature should assess and choose a proper environment such that they maximize their respective fitness. Some species may need to choose where to stand or perch in order to pass unnoticed to predators or prey. Others may do so to efficiently thermoregulate. Ectothermic animals exhibit this behavior in an obligate manner. However, endothermic species may also behaviorally thermoregulate. We think this is the case for the red-necked Nightjar. This is a nocturnal long-distance migratory bird that breeds in the Iberian Peninsula and North Africa. We have been monitoring a population since 2009 in southwest Spain, in the Doñana National Park. The red-necked Nightjar is an insectivore that uses a sit-and-wait strategy where individuals sit tight on the ground and sally out to catch insects that fly past. Naturally, Nightjars must have used open and vegetated patches as a nocturnal hunting platform to provide unobstructed views of the sky, on the lookout for insects flying by. Nowadays, they also use the bare surface of artificial gravel or asphalt-paved roads primarily to hunt, but they also appear to use them to thermoregulate. In a previous study, it was suggested that substrate choice helps Nightjars to minimize energy expenditure in keeping their body temperature constant during adverse weather conditions. This is because, much more than sun, gravel and asphalt roads convert sun into heat that is accumulated during the day and slowly dissipated during the nights. They therefore provide Nightjars with a relatively warm surface to perch on. The potential intrinsic and environmental factors that may modulate this behavioral decision of where to sit and hunt have not been investigated. For example, we think that asphalt is warmer than gravel, and that sitting on warm substrate might be especially relevant if the night is cold. If individuals are small, because smaller individuals lose heat relatively faster, and at the beginning of the night when the roads are still warm. To test this hypothesis, we carry out regular car surveys at 4 7-day intervals along a circuit of roads crisscrossing our study area, and capture Nightjars found sitting on roads at night using a flashlight and a butterfly nets, as you can see in this video. The capturer slowly approaches the individual, dazzling it with his flashlights, so that when he or she is close enough, he is able to capture the Nightjar with the butterfly nets. After we caught the bird, we recorded its body mass, the sex and age of the individual, its reproductive status based on its incubation patch, and the time. With this, we later infer the air temperature and time relative to sunset upon its capture. We analyze whether the use of asphalt versus gravel depending on any of these variables, because asphalt is generally warmer than gravel. We ran a GLMM, and as explanatory fixed variables, we included body mass, reproductive status, sex, time, and temperature during catching. And as a random variable, we included year and ring number of each individual. We also included all the interaction between these variables, since we had a priori reasons to believe that they were biologically relevant. The results showed us that Nightjars don't just sit around randomly. They appear to make complex decisions that are sensitive to environmental factors, but also to intrinsic individual features. Even the 5-wave interaction was statistically significant, suggesting that substrate is determined in complex interactive manners. The primary effects that we found are The smaller they are, the most they use asphalt, especially at the beginning of the nights. The warmer it gets at night, the more they use asphalt, especially in males. And the smaller they are, the more they use asphalt, especially when they have chicks. So overall, as predicted, it is the smaller nightjars that make more use of asphalt, a pattern that becomes even more evident at the beginning of the night, when the roads are still warm. However, there are also some effects that operated in unexpected directions. For instance, females, the sex which we expected to be in greater need of saving energy during the night because they spend more energy during daytime incubation, do not follow this pattern. In addition, nightjars use more the asphalt when it is hot at night than when it is cold. Interestingly, this pattern appears to be absent in juveniles, suggesting that the thermoregulatory advantages of choosing on which type of road to sit for hunting is not important for these individuals. Alternatively, juveniles might lack the information and experience needed to replicate the adult's behavior. In summary, nightjars don't just sit around and wait. There are several individual and environmental variables that have complex interactive effects on their nocturnal hunting's substrate choice, which we believe help them save energy and thereby increase fitness. Thank you so much for your attention.